So this is review 2.15, the last review in polynomials. Keep in mind you are preparing for a unit test, so you've got 3 of these reviews to look at and 2 quizzes. So most of what you see here is just the content that went from since our last quiz. So that would have been 2.12 to 2.15 and a spring break in between. So there's a lot of material that needs to come back. Let's take a look at this, listing all possible rational roots. Keep in mind this would be plus or minus the factors of the constant term, which are 8, divided by the factors of the leading coefficient. So the factors of the leading coefficient, 3. So plus or minus factors of 8 over plus or minus factors of 3. That's plus or minus 1, 2, 4, 8 over 1 and 3. So my total list is everything in the numerator divided by 1, and everything in the numerator divided by 3. 1/3, 2/3, 4/3, and 8/3. So those are all the possible rational roots for this polynomial. Factor completely and find all roots. The first one you see here, this is not a trick question. This is the sum of cubes. Remember, a cubed plus b cubed is a plus b. A squared minus ab plus b squared. The way we remembered that was this has the same sign as what you see right there. This has the opposite sign, and this one is always positive. So in this case, when I factor the polynomial you see there, this will be x plus 3, x squared minus 3x plus 9. So to find all of the roots, so this is our polynomial f of x, you set each equal to 0. So when x plus 3 equals 0, that means x equal negative 3. So that is one of my roots. When x squared minus 3x plus 9 equals 0, quadratic formula, x is going to be 3 plus or minus the square root of 9 minus 4 times 9 over 2. So that's negative b plus or minus b squared minus 4ac. So this is x equal 3 plus or minus. That's 9 minus 36. So that is negative 27. Square root of negative 27. All of that over 2. I'm going to go ahead and take over some more room from over here. So that is 3 plus or minus square root of negative 27 over 2. So that is 3 plus or minus the square root of 9 times negative 3 over 2. So that is 3 plus or minus the square root of 9 is 3. All of that over 2. Square root of negative 3, that is going to be what, the square root of 3i. So this is 3 plus or minus 3i square root of 3 over 2. So back over here, and sorry I ran out of room, so I was listing the roots. So I've got negative 3, and then I'm going to have 3 halves plus or minus 3 halves square root of 3i. Those are my roots. My complete factorization is x plus 3, and then it's going to be x minus 3 halves minus 3 halves square root of 3i, and x minus 3 halves plus 3 halves square root of 3i. So that was a third degree. It has 3 roots. It has 3 factors. Let's move on to the right side of this problem. Hopefully I have room here. This is something with 4 terms. The only way I learned to factor this was by grouping. it looks like in those first terms I can take out an x squared, and I'm left with 2x plus 1. And let me back up. This does not factor by grouping. So I'm going to have to look and see what are my possible rational roots. Okay, so I tried grouping, it doesn't work. My possible roots are plus or minus the factors of 14 over the factors of 2. So that's plus or minus 1, 2, 7, 14, 1/2, 2/2, 7/2, and 14/2. That is the list. Okay. Now if I look and see what happens when I add these up, 2 plus 1 is 3. 3 minus 17 is negative 14. Negative 14 plus 14 is 0. So the coefficients add to 0. That means that x equal 1 is a root. So if I do synthetic division with a 1, then I've got 2, 1, minus 17, 14. So that tells me that f of x is x minus 1 and 2x squared plus 3x minus 14. So are there numbers that add to that multiply to negative 28 and add to positive 3? So I'm looking for numbers that multiply to negative 28 and add to positive 3. It looks like maybe a 7 and a negative 4 multiplies to negative 28, adds to positive 3. So I can write this as 2x squared plus 7x minus 4x minus 14. And so that is x, 2x plus 7 minus 2, 2x plus 7. So this is x minus 2, 2x plus 7. Okay. So my final factorization is f of x equals x minus 1, the first factor that I found, x minus 2, and 2x plus 7. If I set each of those equal to 0, my roots are 1, 2, and it looks like negative 7/2. Okay? Next question, write a polynomial of least degree with real coefficients and roots of 2 and 1 plus root 2 of I. So if this polynomial has real coefficients, it must be x minus 2, that is one factor, x minus 1 plus root 2i, x minus 1 minus root 2 of I. Okay. So now it's just a matter of multiplying those last two terms that you see together. So let's find space for that. X minus 1 minus root 2 of I, and then x minus 1 plus root 2 of I. So this is x squared minus x, and then x root 2 of I. Next line, minus x plus 1 minus root 2 of I, and then minus x root 2i, and root 2i, and then what I see next is minus square root of 2 times square root of 2 is just 2 I squared, but I squared is negative 1, so this just equals 2. Okay, so if I bring all of that together, this is x squared minus 2x. You'll see this term cancels right here. This cancels here. So x squared minus 2x, and it looks like a plus 3. So f of x equals x minus 2, x squared minus 2x plus 3. And multiplying these two terms together, x minus 2, x squared minus 2x plus 3. X cubed minus 2x squared plus 3x minus 2x squared, 4x minus 6. So f of x equal x cubed minus 4x squared plus 7x minus 6. Questions about a polynomial, okay? What is the degree of this polynomial? Is the leading coefficient positive or negative? First of all, I know that this is an even degree, okay? I know that the leading coefficient has to be positive here. In this case, I see how many roots? 1, 2, 3, 4 roots. So this is a 4th degree polynomial. And limit notation. The limit as x approaches negative infinity of f of x. So as the x values go to the left to negative infinity, the y values, they approach positive infinity. And then I'm running out of space, but let me write the other one. The limit as x approaches positive infinity of f of x, my graph also approaches positive infinity. So those are the two limits that describe the end behavior. What are the x-intercepts? Those are the points negative 4, 0, negative 2, 0, 1, 0, and 4, 0. What is the y-intercept? That looks like the point 0, 1. Remember, x-intercepts are where y is 0, y-intercepts are where x is 0. Write the exact equation of the polynomial in factored form. You do not need to multiply out the terms. So this polynomial is going to be f of x equal some leading coefficient, and the factors are going to be x plus 4, x plus 2, x minus 1, x minus 4. Okay, but we know that f of 0, when you plug x equal to 0, you have to get a positive 1. So I know that 1 has to equal a. When I plug in a 0, I get, this is 4, 2, negative 1, negative 4. So that is negative 16. So then it becomes what? Positive 32. So 1 equal 32a. That means a is equal to 1 over 32. So this final polynomial is f of x equal 1 over 32, x plus 4, x plus 2, x minus 1, x minus 4. Okay? Problem number 5. I have a 5th degree polynomial. I give it in standard form and I give it in factored form. What is the degree? This is a 5th degree. What's the leading coefficient? There's a 1 in front of that x to the 5th term. What is this in behavior in limit notation? So this is an odd degree polynomial, positive coefficient. It's going to look like this. So as the x values go to negative infinity, the y values go to negative infinity. As the x values go to positive infinity, the y values go to positive infinity. What are the x-intercepts? Those are the points negative 1, 0, 2, 0, negative 3, 0, and 3, 0. What is the y-intercept? The y-intercept is what you get when x is 0. That's best seen by using this form of the equation here. If x is 0, you get a negative 36. So the y-intercept is 0, negative 36. You could get the same thing if you plugged in this bottom equation. It's just more work, okay? Are there any roots with multiplicity? Yes. There is a multiplicity of 2 at x equal 2 because I have that root squared. And then I'm asked to graph this, okay? So let's first look at what are all of our roots. So at negative 1, 0. And what I will also do here, let me back up. Let's just use green for where I cross and red where I do not cross. So at x equal 2, I do not cross the axis. So multiplicity of 2. So I'm going to put a red dot right there. All the other roots, I will cross the axis. So at negative 1 and at negative 3 and at positive 3. Okay, so those are the 4 roots. And I also have, 0, negative 36. So somewhere around here. Okay, and I know that this graph has to start, it has to end here and up here. So I know I'm starting down below, and I know that I cross, and then there's one place where I do not cross the axis. So the only thing this graph can do is it has to go up, has to come down here. It cannot cross the axis here, and it has to go up this way, okay? So that is a rough representation of this graph. I have end behavior, where it crosses the axis, where the y-intercept, and where it just touches the axis. Looking at a polynomial here, is this an even degree or odd degree? Well, the end behavior, it tends to go up in both directions. If they both go up or both go down, that has to be even. Is the leading coefficient positive or negative? In this case, it's positive if both of those are going up. Absolute minimum. There is an absolute minimum at negative 0.69, negative 8.1. Relative minimum. There is a relative minimum at the point 2, 0. Absolute maximum. There is no absolute maximum. This graph heads off toward positive infinity. Relative maximum. There is a relative maximum at 1.53, 16.2. Intervals of increase. So as I travel from left to right, I am decreasing from negative infinity to negative 0.69. So negative infinity to negative 0.69, that's an interval of decrease. And then from negative 0.69 to 1.53, that is an interval of increase. From 1.53 to 2, that's an interval of decrease. So 1.53 to 2, that's an interval of decrease. And then from 2 to infinity, that is an interval of increase. Okay. Problem 7, performing indicated operations. The way we did this one on the left, we found that it's pretty easy just to create a grid. 2x plus 3, x squared minus 4x plus 4. So this is 2x cubed minus 8x squared plus 8x, 3x squared minus 12x plus 12. So that is 2x cubed minus 5x squared. 12 minus 8, that's minus 4x plus 12. The next one, 2x plus 1 cubed. So 2 choices here. I can do 2x plus 1 times 2x plus 1 times 2x plus 1. Do all of that, or I can use the fact that a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. You can do it whichever way you want. I'm going to choose the latter of those. So if I cube the first term, that's 8x cubed plus 3, 2x squared times 1 plus 3, 2x times 1 squared plus 1 cubed. That is 8x cubed plus 12x squared plus 6x plus 1. Okay? Long division. So, if we can remember long division, x minus 2, and I'm dividing that into 2x cubed minus 3x squared minus 8. What do I multiply x by to get 2x cubed? That's 2x squared. So when I multiply that, I get 2x cubed minus 4x squared. Big thing, people make mistakes. You have to subtract all of that. So the first term cancels. The second term just becomes x squared, and I've got this minus 8. What do I multiply x by to get x squared? That is an x. So this gives me x squared minus 2x. I have to subtract all of this. When I do that, I'm left with, I'm running out of space here, but I'll write it, 2x minus 8. What do I multiply x by to get a 2x? That is a 2. That gives me what? 2x minus 4. Subtract all of this, and that gives me a negative 4, which is my remainder. Okay, so the answer is 2x squared plus x plus 2 minus 4 divided by x minus 2. Okay, problem number 9. This is a tough one, but it makes you think, okay? Look at this polynomial. Which of the choices could possibly be the list of all roots, okay? When I look at this graph, there is only one real root, and that is at negative 2. So this can't be possible because that's got a 2 instead of a negative 2. So right now, it's either B, C, or D, okay? Now, the other thing I know is that if I've got a irrational or a complex root to have real coefficients, I've got to have corresponding roots, okay? So in this case, if you look at it, it can't be D because if you look at the number of turns, I've got 1, 2, 3 turns. This has to be in at least a 4th degree polynomial. It can't be D. So if you look at it, it's either B or C. The only difference between these is if you'll look at it right here, this has a complex root but not its conjugate. So the only one that has conjugates for all the irrational and complex is this one. So it has to be C. This turned into a bonus last year because they couldn't get it, but you guys can handle something like that. Graph and write the possible equation for a 6th degree polynomial that has an absolute maximum at the point shown and zeros at plus or minus 3 and plus or minus 1. Also, it only crosses the graph at 3 and negative 1. Okay, so it's going to cross the graph. Let's draw that. At 3, 1, 2, 3, crosses the graph there and there. Okay, so the other roots are going to be negative 3 and positive 1, so it will not cross the graph there. So it does not cross the graph here, and it does not cross the graph there. Okay. So now the fact that it has an absolute maximum at that red dot that you see right here, that means whatever the graph does is going to have to head off to negative infinity. You know, it can do different things, but that's the general shape of what has to happen if I'm going to get an absolute maximum at that point. So in this case, if I start to graph this guy, I know that the first thing, it cannot cross at the first one, so it cannot cross there. It has to cross here. That is my y-intercept and maximum. Cannot cross, has to cross. So that is the only thing that this graph can do. So its x-intercepts are at what? -3, 0, -1, 0, 1, 0, and 3, 0. And what is the equation? Well, the ones where it cannot cross. So if I look at f of x, so let's just write it here, f of x equal, so at -3, so it's going to have x plus 3 as a factor. It's going to have x plus 1, x minus 1, x minus 3. That's fourth degree. But I know that if it does not cross at -3, that has to be squared. And if it does not cross at +1, that has to be squared. So this is my 6th degree polynomial that meets all of those conditions. And that is it.